So up until now, really we've been looking at two kinds of scatterplots. We've been looking at scatterplots that are linear already, which is great, and we can do all of our sort of regression analysis stuff that we looked at through 5C. Or if we found that they weren't linear, if we looked at something that wasn't linear, we just sort of stopped there. We said, all right, that's it. It's not linear, we can't do anything with it, we'll just leave it. Well, now we're going to look at things that aren't linear, so curves, things like that, and we're going to turn them into, we're going to transform them into a linear kind of graph, and that way we can do things like our regression analysis. We can put a regression line on there, we can find the R-squared values, we can find the R values, we can predict more things from it, all those sorts of great things that we can do when the graph is linear. We're going to be able to do that because we're going to transform our non-linear things to make them linear, or at least we're going to do our best attempt at that and then check if we've done it right. So this first option here, and this is just the summary notes that I've just put on Compass. You can see that, find them on Compass. This is kind of like the calculator way to do it. This plot is just making the scatter plot basically, and I'm going to use the data from one of the questions in 6B. So I'll just quickly grab that data, I'll put it in and form a scatter plot. If you already know how to do this, then that's absolutely fine. You might just like to skip ahead a minute in your video. So I'm going to use this data here. This is from 6B. 1, 2, 3, 4, 5, 3, 9, 19. So I've labelled my list and spreadsheet. 1, 2, 3, 4, 5. So it's 3, 9, 19. Just quickly check that. 3, 9, 19, 35, and 51. 35 and 51. So that's all my data put in, and then I'll quickly make my control new page, data and statistics. Now I've got my scatter plot in. You should know how to do this by now. If you're not sure, please come and see me. Oh, here we go. So you can see, see how this data is kind of curving upwards. It's not linear. We can't assume that it's in a straight line. So we could fit a straight line to it now, but we'd pretty quickly see that it wasn't linear. So just heading back to our instructions, we've added our new page, added our columns in, we've labelled them, put in a new page. Then we're just going to fit a regression line now. So we're going to put it on, and then we're going to see what happens. So let's put on our regression line, menu, analyze, regression, show linear a plus bx. This show median, that's actually our 3 median line that we did today. However, I haven't checked into it myself yet, but I'm told that's the 3 median line function. So have a gamble with that and see how you go. Show linear a plus bx. So you can see here we've kind of got above the line, then under, and then above again. It sort of does help us to confirm that it is in fact a curve and not what we were hoping it would be. So let's head back into our instructions. Yes, we've fitted our regression line. Now we need to transform it, and I'm going to tell you this time what we need to transform it as. But later on we're going to learn how to figure that out ourselves, what type of transformation we need to use. So I'm going to tell you now that this is an x squared graph. This particular type of graph is an x squared graph. So we need to apply the x squared transformation in order to make that linear. So what I mean when I say we need to apply the x squared transformation is I'm going to change this axis, and instead of this axis being the x-axis, I'm actually going to put all these values on this axis, so 1, 1.5, all of these values, and I'm going to square them so they become a lot bigger. It's actually going to shift the shape of the curves and drag them into being in a straight line. So instead of plotting x, my independent variable, and y, my dependent variable, I'm now going to do x squared, independent variable, and y, still y, I haven't changed the y, for my dependent variable. So let me just go back to my sheet. So this is transform. I'm going to go back to my list and spreadsheet page, and I'm going to add a new column and title it, and then I'll put in my squared transformation. So that's put the grey box in. So you'll see how I go. I'll come back to this in just a second. So I'm going to go back, so control across to my list and spreadsheet, and in the third column, I might call this column C. In fact, I might be more helpful. I might call this my x squared. So I can quickly see what that is. In fact, that's not how you spell squared. Please forgive me. Not that it really matters anyway. And in this box here, in this equation box, into the equals sign, I'm actually going to put a, because that's the name of my x column, a, and then the little squared sign. So here down you can see what I put in there, a squared. When I hit enter, it's going to ask me if I want to go with the column reference or the variable reference. We're going to go with the variable reference because we've said this is our variable a just here. So we're going to pop that in. So that's squared all these a values, a squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. It's basically just squared all of our a values. So that's what we've called our x squared transformation. So this will be the new parts of the axes, 1, 4, 9, 16, 25, instead of 1, 2, 3, 4, 5, and new pieces of data. So let's head back to our graph, and we'll double check where we are in our document. We've gone back to our lesson spreadsheet, we've added our new column, we've put the equation in the grey box under the title you just made, and we chose, this example says age squared, we chose our x squared. Then we're going to add a new page, data and statistics, and put on the new independent and dependent. So now we're going to put on the x squared and the y instead of the x and the y. Just shift that over. So we're going new graph page. Instead I'm going to put in my x squared, and there's the one that I spelt right. Still I'm going to put in my y, which we call b. And you can see now, actually, this looks far more linear than it did before. It's taken out that curve, which we want, but we're going to check that in a minute. So add the regression line, C, fit regression line section. So if you're not sure how to add the regression line, menu, analyze, regression, show linear a plus bx, and already it looks a lot more like it's on the line. So it's looking good in terms of our choice for transformation. It's looking like we chose the right thing. Let's do our regression analysis, and we might leave that for now, but that's about finding things like our R values and all that sort of stuff. One last thing, you could do that in your own time if you wanted this sort of stuff. One last thing, let's check with our residual plot that it is linear. So we're going to confirm our assumption of linearity, because it looks linear now, with our residual plot. So analyze, residuals, show residual plot. So this is my residual plot. I can't see any clear pattern in my residual plot at all. So it looks like that data is just randomly dotted around. Fantastic. I was hoping there would be no pattern. Therefore, we've confirmed the assumption that when we graph x squared against y instead of x against y, that we have in fact made it linear. We've done a successful transformation, and now that's great. We can do all of our analyses, our R's, our regression lines, our predictions, all the stuff that we did in our full regression analysis video. That is pretty much how you transform something. We're going to look a bit more at different types of transformations in past videos, in future videos, and decide which one's the best. But as a general process, that's how you'll do it on your calculator to transform something.